Okay, linear functions, a little test we gave out. Hopefully this didn't cause you too much trouble. Stuff's kind of old, but that's alright. First couple, tell whether we have a linear function. So we're looking for common differences between x and y. So 0, 0, 1, 1, 2, 4, 3, 9, 4, 6. Hopefully you recognize, looking at these, that y in this case is x squared. And if it's x squared, then that's quadratic, which is very not linear. So this one is not. Okay, number 2, we can look for a pattern here. This is plus 2, plus 2, plus 2. This is minus 3, minus 3, minus 3. So we have a constant rate of change. So if they all have a constant slope, this is linear. Yes. Okay. 3, Lily plans to volunteer for 45 hours, 3 hours per week. 45 minus 3x gives the number of hours she has left to work after x weeks. Graph the function, find its intercepts. What does each intercept represent? Alright, so we're going to make a lazy kind of graph here. We're going to find our x and y intercepts. So let's say, what's x when y is 0? So how can we make 0 equal 45 minus 3x? So that's going to be negative 45 equals negative 3x, or x equals positive 15. So we're going to have one point here at 15, 0. Okay. And then to find our y-intercept, we set x equal to 0. So if we say y, or f of x, equals 45 minus 3 times 0. And that's just going to be y equals 45. So we're going to have this other point up here. So here's our linear function, downward sloping. What does each intercept represents? So when x is 0, we're talking about time here. This is time. No, that's not right. Sorry. This is weeks. And y represents hours. Okay. So this y-intercept represents the number of hours that she started with. So after 0 weeks, she had to work 45 hours. And our purple x-intercept, that's how many weeks it would take for her to be done with her hours. So once she reaches this point at 15 weeks, she's finished. So the y-intercept is where we started. X-intercept is where we ended. That's it. Use intercepts to graph the line described by that. Okay, same idea. Cheap graph here. Find our y-intercept, I guess we can do first by setting x equal to 0. So that's just going to be negative 3y equals 6, because 2 times 0 is 0. So that really goes away. Divide everything by, this is a y also. We divide everything by negative 3. We get y is negative 2. And let's do that in a different color. Let's say this was supposed to be blue. So negative 2, 0, or 0, negative 2 is our y-intercept. If we can get our x-intercept by setting y equal to 0, so 2x equals 6, because again, for the same reason, 3 times 0 is nothing. We divide everything by 2, we get x equals 3. So our second point is 3, 0. And the reason why intercepts are kind of cool with linear functions is because if you find both of those, which is pretty easy to do because you just substitute in 0, and 0 makes math kind of easy, you have 2 points, and 2 points is enough to construct a line. Unlike parabolas, which required how many points? I'll let you think about that. That's right, 3 points to make a parabola. Alright, find the slope, tell what the slope represents. So remember, slope is change in y over change in x. Or if you're not down with that, we say y2 minus y1 divided by x2 minus x1. So change in x, change in y. So our change in y here is how far is it from 68 to 25.5. So 68 minus 25.5 is 42.5. Hopefully. I don't know, I might be wrong, but it sounds right. 77. Yeah, that works. Over the change in x. So x goes from 8 to 3. So we get a slope that looks like 42.5 divided by 5. You could divide that out, I guess. Let's say 42.5 divided by 5. That's 8.5. So our slope's like 8.5 over 1. So in this case, what does that represent? So we're talking about cost per tickets. So it's going to be $8.5 per ticket. That's 5, right? 5. Alright, number 6, water in the tank. This one's a little bit easier. These numbers are smaller. We know this is going to be negative, so we can start off right there. I know this is negative, and I know this is not needed anymore, so I'm going to erase it. It's going to be negative something. The change in y here, 76 minus 40 is 36. And then from 2 to 5 is a difference of 3. So we get 36 over 3, which simplifies nice and easily to negative 12. So this slope, it's water in feet over time. So this is saying we're losing 12 feet of water per second. Wow, that's a lot of water per second. Must be a big tank. Alright, so that's that. Last one for this section. So positive slope this time. That's not the best triangle, but whatever. The change in y, it's going up by 5. The change in x is going up by 5. So our slope here is just 1, or 1 over 1. So temperature and times, this means our temperature is increasing at a rate of 1 degree Fahrenheit per hour. That's it. Okay. Tell whether it's direct variation. We've talked about this one where y has to equal kx for this to be true, which means you can't have anything over here. So it's got to look like y equals 2x, or y equals 1/3 x, or y equals 347.8 x. You can't have any plus or minus. As soon as you have that, it doesn't work anymore. Okay? So one of the key things that'll make this work is that when x is 0, y also has to be 0. So that's one of our pretty good conditions here. So we look, we don't even have a good steady rate here. This is plus 3, plus 3, plus 3, plus 3, and plus 4, plus 4. So we can see that our slope here, our rate of change, is always either 3 over 3 or 4 over 4, which is just 1. So this is going to look something like y equals 1 times x. And then we just look, will this rule hold up by itself? Can I simply take x times 1 and get it to equal y? And the answer is no. If that was the case, x and y would have to be exactly the same, and they're not. So that's that. Okay, our actual equation here would have to be plus 5. Because if we tried like 9 here, 1 times 9, we want it to equal 14, so we have to add 5 to that. So since we have plus 5, it is not direct variation. Not. Alright, number 10. We look for a pattern. We've got plus 4, minus 2, plus 4, minus 2, plus 4, and minus. Minus. It's supposed to be a minus. Looks like a plus sign. Really, it's a minus. So we have our constant slope here. It's 4 over negative 2, which is just going to be negative 2x. And then we see, will that work on its own? So if we try, I don't know, 6. So if we say negative 2 times, oh man, I'm sorry. Hold on. Oh, I'm making silly mistakes. Why is it not 2? Because slope doesn't go x over y, it goes change in y over change in x. My bad. So this is actually negative 2 over 4, or negative 1/2 x. Sorry. Nobody's perfect. So we try this again, for reals this time. So if we take negative half of 6, well, half of 6 is 3, and the negative of that is negative 3. So yes, this works out pretty well here. You could try it on all the other ones, you're going to get the same thing. So this is directly variated, direct variation. And our constant of variation is just whatever k is, which in this case is negative 1/2. So yes, negative 1/2. Okay. Let's see, write this equation 2x minus 2y equals 4 in slope-intercept form. Well, slope-intercept just means y equals mx plus b. So we're going to have to take our 2x and move it to the other side. So we're going to end up with negative 2y minus 2x plus 4. We need y to be by itself, so we divide everything by negative 2. So we get y equals, this is going to cancel out, so it's just x. 4 divided by negative 2 is 2. Okay, if you wanted a graph for that, when x is 0, y would be negative 2. When x is 2, 2 minus 2 is 0. So we get a graph that looks kind of like that. Alright. Graph a line with a slope 1/3 that contains point 4/3. Okay. Graph it. I don't want to graph it, but we'll graph it anyway. That's a bad line. So what we can do, if all it wants us to do is graph it, I know what you're thinking, slope, point, we should use point slope form, and yes, that would be very good, but we don't actually care what the equation is, we just want to graph it. So what we can do is we can plot the point it gives us. So if we go negative 4, negative 3, we get something down here-ish. Negative 4, negative 3. And then we just go with the slope. Slope is rise 1, run 3. So we go up 1, and we go over 3. So up 1 would be negative 2. Oh man, I'm making so many silly mistakes tonight. Negative 2 is y, not x. 3 to the right will make this negative 1. So negative 1, negative 2, and probably could have plotted that a little better. There, that looks better. Okay, if you have 2 points, you have a line. And that's it. Alright, number 12, write an equation in slope-intercept form that goes through this line with those points. So this time we need the equation, so guess what? This time we actually get to use point-slope form. So hooray. So point-slope form looks kind of like y minus y1 equals m, that's not a very good m, x minus x1. So our slope, to figure that out, remember change in y over change in x. So our y goes from 1 to 3, so that's plus 2. Our x goes from negative 1 to 0, so that's plus 1. So our slope is just going to be 2. For x1, y1, we can use either of these points. I'm going to use one with 0 because I'm lazy and I don't want negatives. So I'm going to say x1 is 0 and y1 is 3. Everything else stays the same, so y minus 3 equals 2 times x minus 0. We get rid of these parentheses here, so y minus 3 equals 2x. 2 times x is 2x. 2 times 0 is just nothing. So that's it. To get y by itself, we got to add 3. So our equation is going to be y equals 2x plus 3. That's it. Happy face. Alright, getting close. Identify which of these lines are parallel. So parallel means same slope. The intercept totally doesn't matter. All we care about is we need the same slope. So our slope for this first one, we have 1, 2, 3, 4 different equations here. So our slope on this one is 1/2, negative 1/2. This is positive 1/2. This is 2, and this one is not quite done for us. We have to move this one around. Hopefully you've seen enough of these, you can be like, oh, I know what the slope is just by seeing it. But if not, that's okay. So this, we'll bring it down here. If we move x to the other side, we get 2y equals negative x, bringing it to the other side, plus 4. We divide it by 2, so we get y equals negative 1 over 2x plus 4, which means our slope here is negative 1/2, which means the lines that are parallel are the very first one and the very last one. That's it. That's it for that one. Okay. Next one, identify which lines are perpendicular. So remember, perpendicular means that they have the reverse reciprocal. I think I spelled that right. Which means you take your slope, let's say our slope was 1/3. To be perpendicular, you'd have to flip it and change the sign. So positive 1/3 would become negative 3. If our slope was, I don't know, negative 2, we'd have to flip it. So 2 over 1 is, if you flip it, you get 1/2. You change the sign from negative to positive. So that's what we're looking for. So our slopes as we have them. We have this one, our slope is 3. This, let's separate these real quick. This looks kind of ugly. There's a 4 here, so we're going to have to move the x to the other side. So that's going to be y equals negative 4x minus 1, which means our slope is negative 4. Okay. The slope here is negative 1/3. And this one, our slope is 1/3. So we're looking to flip something. So this 4 has nothing to do with anything. This can go away. So 3 is definitely part of this answer. And we sort of did it over here. If we take the reverse reciprocal of 3, we have to flip it over. So 3 over 1 would become 1/3. And we change the sign, so that would be negative 1/3. So our two perpendicular lines are the first one and the third one. There you go. Drink time. Okay. 15. Write an equation in slope-intercept form line that passes through 0, 6 and is parallel to this line right here. Okay. So if we're doing that, we have a point, and since it's parallel, we keep saying it, that means same slope. So we have point and we have the slope, which means we can use point slope. So y minus y1 mx minus x1. We fill in our numbers here. Our slope is 2. x1 is 0. y1 is 6. Let's hold on. Let's not do this all in red. Let's say 0, 6, and our slope is 2, 6, and now I'm backwards. Ugh. Okay. So y minus 6 equals 2 times x minus 0. So just like last time, nothing happens on the left yet. 2 times x is 2x. 2 times 0 is nothing. To get y by itself, we have to add 6. So our new equation is going to be y equals 2x plus 6. And then you can compare that to what we started with and be like, oh, look, they both have 2x. And why do they both have 2x? Because, duh, they're parallel, which means they have the same slope. That was the point. Okay, all that's going to change is our y-intercept. We could have actually skipped all this work if you recognize that 0, 6 is the y-intercept, and b in our y equals mx plus b mess, b is the y-intercept. So if it tells us the y-intercept, we probably could have, put this together without the work. But this little form is so much fun to do. How could you resist working that out? Right? Right. Okay. So the second one, write an equation in slope-intercept form that's perpendicular this time and passes through 4, 6. So remember, same idea, except instead of the same slope, we're going to have the reverse reciprocal slope. So we need to take our regular slope, which was 1, flip it over, which coincidentally is just 1, and then make it the opposite sign, so a positive 1 will become negative 1. Okay, here's our coordinates. So x1 is going to be 4, y1 is going to be 6, and then we just fill in our happy letters. So again, nothing happens on the left yet. Negative 1 times x, negative 1x, negative 1 times, negative 1 times negative 4 is positive 4. To get y by itself, we add 6, 6. So y is going to equal negative x, or negative 1x, plus 10. And that's it. Alright, 4 more. Graph f of x and g of x, then describe transformations from those two. I'm done graphing. Let's look at how these change. So 8x to 4x. I guess we can sort of lazy graph it. 8x is going to be like super steep looking graph. Whoops. And since there's no plus or minus, we know that it'll go through the origin. 4x will also go through the origin, but it will not be as steep. Probably be steeper than that, but that looks pretty good. Make this a little steeper. So here's our two graphs. Describe the transformation. We said it. It's less steep. You'd also say it's slightly rotated, because if we kept rotating this, we'd get to the same line. All lines are pretty much rotations of each other, given the fact that they're lines. I'll let you think about that. So that's it. Y-intercept doesn't change because the y-intercept is always 0, 0, so it's just the change in slope. 18 negative x plus 2 negative x minus 1. Well, these ones have the same slope, so they're going to be parallel. So our only transformation is our y-intercept went from positive 2 to negative 1, which means this is going to be a translation. And since it's from 2 to negative 1, we say that's, I wanted to say negative 3, but we can just say 3 down. And that's it. Hooray. And 19, they stick them together, so we have 3x and 6x, which means our slopes are going to be different. So this is going to get steeper. And this y-intercept, it's not written there, but this would be 3x plus 0, and this is 3x minus 1, so that means it's being translated 1 unit down. And that's about it. You could always graph these, put them on your calculator, and look at how they're different, but hopefully after a whole year of this, you can recognize what these lines would look like using your awesome mathematical prowess. Or you could use a calculator, whatever works. Last one, airport parking lot. Ugh, airports. Entry fee of $2 plus $2.50 for every hour that your car is parked. Okay. Total charge is 2.5x plus 2. Okay. How this graph of this function changed, the entry fee is increased to $3.50. So just the fee Just the fee is not the hourly rate, so this is going to affect what? It's not the slope. And there's only one other thing, which means it's got to change the y-intercept. So our graph, if our y-intercept is going from 2 to 350, means that would translate up 1.5 units. If it says if the hourly rate is reduced to $2.25, well, the key word there is rate, which means that's going to be changing the slope. If it's going from 2.5 to 2.25, it's getting less steep, so it's getting, I don't think narrower is the word I want, so I'm just going to say less steep. Some solid math vocabulary there. Less steeperness. I would stick with this. So if the y-intercept changes, it translates up or down. If the slope changes, it just changes how steep your linear function is. And that is about it for this. So goodbye. Have a good weekend. Okay.